Martin Kay was a British computer scientist and a pioneer in the field of computational linguistics. He is particularly known for his work in machine translation and for introducing key concepts such as chart parsing and functional unification grammar. He also made significant contributions to the application of finite-state automata in computational phonology and morphology. Throughout his career, he held positions at prominent institutions like the Rand Corporation, the University of California, Irvine, and Xerox Palo Alto Research Center Park, and was a professor at Stanford University. He was honored with the Lifetime Achievement Award from the Association for Computational Linguistics in 2005. Martin Kay was born in Edgware, Middlesex, Great Britain, in 1935. He was a polyglot who studied modern and medieval languages at Trinity College, Cambridge, where he earned his MA in 1961. His early interest in the automation of translation led him to the Cambridge Language Research Unit in 1958, one of the earliest centers for what would become computational linguistics. This work marked the beginning of his pioneering career in a field that was just emerging. In 1961, he moved to the United States to work for the Rand Corporation, where he became the head of research in linguistics and machine translation. Thanks for reading No Mic Podcast Scribed by Facelesslingjutsu. Subscribe for free to receive new posts and support my work. Rules of Interpretation and Approach to the Problem of Computation in the Semantics of Natural Language 1962. This paper, presented at a key early conference, tackled the complex problem of computational semantics. It explored how to computationally represent and interpret the meaning of natural language, moving beyond simple syntactic analysis. The work laid early groundwork for formalizing the relationship between a sentence's structure and its meaning, which is a fundamental goal of computational linguistics. A Parsing Procedure 1962. Also from the 1962 IFIP Congress, this paper introduced a novel parsing procedure. At a time when computational linguistics was still in its infancy, developing efficient and reliable parsing algorithms was crucial for processing natural language text. This work contributed to the foundational methods used to analyze the grammatical structure of sentences, a prerequisite for almost all subsequent natural language processing tasks. A General Procedure for Rewriting Strings 1964. This paper presented a generalized method for rewriting strings, a core operation in formal language theory and early computational linguistics. It proposed a flexible and powerful mechanism for manipulating symbolic representations, which could be applied to various linguistic tasks like morphological analysis, syntactic parsing, and even phonological rule application. The Logic of Cognate Recognition in Historical Linguistics 1964. This work from Rand Corporation applied computational methods to historical linguistics. It developed a logical framework for automatically identifying cognates, words from different languages that share a common origin. This was a pioneering effort to use computers to assist in the comparative method of historical linguistics, a domain traditionally reliant on manual analysis. A Parsing Program for Categorical Grammars 1964. This publication focused on creating a parsing program specifically for categorical grammars. Unlike phrase structure grammars, categorical grammars use a different formal approach to describe syntax, treating grammatical categories as functions. This paper was a key step in exploring and implementing different formalisms for natural language parsing. The Tabular Parser 1966. This paper introduced the tabular parser, a program designed for both phrase structure and dependency grammars. The tabular approach, a precursor to modern chart parsing, stored intermediate results in a table to avoid redundant computations. This was a significant advance in parsing efficiency and flexibility, allowing for the analysis of different grammatical theories within a single framework. The Computer System to Aid the Linguistic Field Worker 1969. This paper described a practical application of computational linguistics, a computer system designed to assist linguistic field workers. The system aimed to automate tasks like data collation, concordance generation, and morphological analysis, helping linguists who were documenting and analyzing previously unstudied languages. The MIND System, the Morphological Analysis Program 1970. Co-authored with Gary R. Martins, this work details the morphological analysis program within the larger MIND system. The program was a sophisticated tool for breaking down words into their constituent morphemes, e.g. prefixes, stems, suffixes, a crucial step for a wide range of natural language processing applications, including machine translation and information retrieval. Automatic Translation of Natural Languages 1973. Published in the special Daedalus issue on language, this paper provided a broad overview of automatic translation. It summarized the state of the art in machine translation at the time, discussing both the successes and the significant challenges that remained. The article helped frame the problem for a wider academic audience, placing machine translation in the broader context of computational and human language. Linguistics and Information Science 1973. This book, co-authored by Karen Spark-Jones and Martin K., was one of the early works to explore the intersection of linguistics and the burgeoning field of information science. It aimed to show how linguistic theories and methods could be applied to practical problems in information retrieval. The book covered topics such as the automatic analysis of text, the use of thesauri, and early ideas about natural language understanding, laying foundational groundwork for later developments in computational linguistics and natural language processing. Natural Language in Information Science 1977. Edited with D. E. Walker and Hans Karl Gren, this volume came out of a conference on the use of natural language in information systems. The book compiles various papers and research contributions from that time, reflecting the state of the art in the mid-1970s. It addressed topics like the representation of meaning, text summarization, and query languages, providing a snapshot of the research community's efforts to move beyond simple keyword-based search and toward more sophisticated, language-aware systems. Theoretical Issues in the Design of a Translator's Workstation c. 1980s. This work addressed the theoretical and practical considerations in designing a translator's workstation, a system to assist human translators. It discussed the features such a system would need, including tools for terminology management, text alignment, and automatic suggestion of translations, laying the groundwork for what would become modern computer-assisted translation CAT tools. The proper place of semantics in machine translation. Proceedings of the 19th Annual Meeting of the Association for Computational Linguistics ACL, 1981. This is one of the earliest and most foundational papers by Martin K. on the topic of machine translation, where he first introduces his influential perspective on the role of semantics. The paper argues that a successful machine translation system cannot simply be a matter of word-for-word or even syntactic-to-syntactic mapping. Instead, he contends that the system must perform a semantic analysis of the source text to capture its intended meaning. This is crucial for resolving ambiguities and ensuring the translated output is both accurate and natural sounding. This paper set the stage for much of his later work and sparked a debate that has influenced machine translation research ever since. A Charting Model for Machine Translation. ACL Conference on Applied Natural Language Processing, 1983. This paper introduces the concept of using a chart parser as a foundational model for machine translation. A chart parser is a dynamic programming algorithm used in computational linguistics to parse sentences efficiently by storing partial parses in a data structure known as a chart. K's work demonstrates how this method can be adapted for the complex task of machine translation, allowing the system to handle ambiguities and create a lattice of possible translations before selecting the best one. This innovative approach laid the groundwork for many subsequent parsing and translation systems by emphasizing efficiency and the systematic exploration of linguistic possibilities. Functional Unification Grammar, a Formalism for Machine Translation 1984. This paper, a key contribution to the field, introduced functional unification grammar FUG. FUG is a formalism that uses unification, a powerful pattern matching operation, to combine linguistic feature structures. It was proposed as an elegant and computationally tractable framework particularly suited for machine translation and other complex natural language understanding tasks. Parsing in Free Word Order Languages 1985. Co-authored with Laurie Karttunen, this paper addressed the challenge of parsing languages with free or flexible word order. Unlike languages like English, where word order is relatively fixed, languages like German or Russian allow for more flexible sentence structure. The paper presented a solution using functional unification grammar, demonstrating the formalism's power in handling a wider range of linguistic phenomena. Unification in Grammar 1985. This paper provided a general overview of the concept of unification as a core operation in grammar. It explained how this logical and computational concept could be used to elegantly and efficiently process and represent linguistic information, such as agreement between words and the combination of phrases. The proper place of semantics in machine translation. In T. Nishida ed. Readings in Machine Translation, 1989. This publication is a reprint or a revised version of a key paper on machine translation, included in a collection of influential works edited by T. Nishida. Martin K.'s contribution emphasizes the critical role of semantics in achieving accurate and high-quality machine translation. He argues against the prevailing view at the time that a system could rely solely on syntactic and lexical rules. Instead, he proposes that a robust translation system must be able to understand the meaning behind the words to resolve ambiguities and produce a more faithful translation. This paper solidified his position as a proponent of meaning-based translation approaches. Regular Models of Phonological Rule Systems 1994. Co-authored with R. M. Kaplan, this paper revisited a fundamental area of linguistics, phonology. It argued that regular expressions and finite state automata could be used to model and process a wide range of phonological rules, such as those governing sound changes. This work brought a powerful and computationally elegant formalism to the study of phonology. Verb Mobile, a translation system for face-to-face dialogue 1994. This book, written with Jean-Marc Gorin and Peter Norvig, documents the Verb Mobile project, a major German initiative from the 1990s. The project's goal was to build a machine translation system for spoken, face-to-face dialogue in specific domains, like travel planning. The book provides a detailed account of the project's architecture, including its use of speech recognition, parsing, semantic analysis, and speech synthesis. It represents a significant step forward in the field, moving beyond text-based translation to tackle the complexities of spoken language, including conversational features, prosody, and the need for near real-time processing. An Introduction to Machine Translation 1992. Authored by W. John Hutchins and Harold L. Summers, this text is widely considered a foundational textbook in the field of machine translation (MT). It offers a comprehensive overview of the history, theories, and techniques of MT up to the early 1990s. The book covers various approaches, including rule-based systems, statistical methods, and example-based MT, providing both historical context and technical details. It served as a key resource for students and researchers, formalizing the discipline and summarizing decades of research in a single, accessible volume. Handbook of Computational Linguistics 2003. Edited by Ruslan Mitkoff, this handbook is a comprehensive reference work that covers the vast scope of computational linguistics. The introduction, often written by the editor, sets the stage for the entire volume, outlining the field's history, key subfields like natural language processing, machine translation, and speech recognition, and major challenges. It provides a structured overview, helping to orient readers and researchers by mapping out the landscape of the discipline in the early 2000s and serving as a crucial reference for anyone studying or working in the field. Substraying Alignment Using Suffix Trees 2004. This paper introduced the use of suffix trees for efficient substraying alignment. This technique is highly useful in computational linguistics for tasks like finding similar phrases or aligning parallel text, e.g. a document and its translation, which are crucial for building statistical machine translation systems and other data-driven NLP applications. 2011, co-authored Gazing and Typing Activities During Translation, a comparative study of translation units of professional and student translators with Michael Carl, a study on human translation processes. 2014, Does a computational linguist have to be a linguist for Coling 2014. 2015, co-authored a book titled Translation Studies in Computational Linguistics.